saw that very less number of, we have we have very less number of molecules which are having a very high energy, which is greater than threshold energy. But if we have all the molecules which are having energy greater than threshold energy, then it is going to be not very much productive, because if we have a very large amount of molecules with a very fast energy, then the orientation will not be very good, and that is why we will not be getting any effective collision. Then we talked about activation energy, and we saw that the progress of reaction, it can be showed in two different graphs for exothermic and endothermic reactions. And then the temperature dependence we saw. And now we are going to look at this was the quantitative look. Qualitative look, I will say, on temperature dependence. That we increase the temperature and the velocity of particles will increase. And if the velocity of a particle will increase, that means more number of particles will be achieving the threshold energy, and that's why the rate will also increase, right? Now we are going to look at the equation that determines the rate of reaction and how it is dependent on temperature. So for that, you will write Arrhenius equation. Arrhenius equation. Please write this with me. The equation which gives the relationship between temperature and rate constant is called Arrhenius equation. It's called Arrhenius equation. So rate constant is K, and Arrhenius proved that K is equal to A into e to the power EA by RT. EA by RT. Okay. So in this equation, we'll write all the terms. What is K? K is the rate constant. What is A? A is Arrhenius constant, or it is known as pre-exponential factor. Okay, so there are two names of A. I can get some space. A is Arrhenius or pre-exponential factor. Okay, then we have EA. EA is activation energy. There is a minus sign on E. Okay, minus EA upon RT, activation energy. R is our gas constant. And T is the temperature. Assalamu alaikum, Razan. How are you? Razan, are you there?
Yes, sir.
Okay. Razan, you're not there in any groups now? Or are you there in any group? You're there in chemistry? You're there in chemistry group. Okay.
Yes,
did you get the timetable, like the test notice that you're going to have a test on Wednesday?
Yes, sir.
Mila up. Okay. small e, Fatima, you know this exponential log e, ये पता है आपको फातिमा? log to the base e नहीं पता है फातिमा? yes or no? turn your mic on and tell me. नहीं सर, नहीं पता है. देखिए e is a constant, ओके, e is a constant. जैसे पाई एक कांस्टेंट होता है ना, वैसे ही आपके पास e क्या है, e एक कांस्टेंट होता है. आप लिखना चाहे तो लिख लें e की वैल्यू, लेकिन ये आपके इसमें काम नहीं आने वाली. ओके, सो द वैल्यू ऑफ e इट इज इक्वल टू 2.718 एंड सो ऑन. It is Euler's number. Okay, write a note here. Write a note. The first point you will write is, see, in this whole equation, this k can change on temperature, right? This k can change on temperature. R is already a constant. It does not depend on any. It does not depend on any reaction. For each and every reaction, it will be same. E is also a constant. It will not depend on any of the reactions. But we have two terms, that is A and EA. The Arrhenius factor and the activation energy. These are what characteristic of a reaction. That means these are specific for a specific reaction. So you'll write first point, A and EA are characteristic for a reaction. Okay, these are known as, these two are collectively known as Arrhenius parameters. Sorry. Now we will first of all take the log on both of the sides. Okay, we'll take the log on both of the sides and then we'll work on this equation. So according to Arrhenius equation, k is equal to A into e to the power minus EA upon RT. Take log on both sides. Whenever we take log, we can take the natural log only. So write ln k is equal to ln A into e to the power minus EA upon RT. Now we have ln and inside we have what? Multiplication. Ln A into B. It will be equal to what? Please write this. See. This will be equal to ln A plus ln E to the power minus EA upon RT. Now this ln means natural log, and natural log, it has a base of E. So what we are writing, log E to the power EA by RT. यहाँ से देखिए log E to the power E में से E cancel हो जाएगा, right? And we'll be only left with, first of all write this. log अगर नहीं आता होगा तो समझना थोड़ा मुश्किल हो सकता है, बट स्टेप बाय स्टेप हम आपको करके दिखा रहे हैं. फर्स्ट ऑफ ऑल माइनस EA अपॉन RT नीचे उतर जाएगा. आई होप यू गाइस नो that if we have ln 10 to the power 2, then this is equal to 2 to the power ln 10, right or not? The power rule. So I will write here minus EA upon RT, and we have ln and also E. Now, log with base 10 of 10 will be equal to 1 because 10 to the power 1 is equal to 10. So ln E will be also what? Ln E is actually what? Log E to the power log E and E. Log E of base E. So this will be equal to 1. And then further we can write ln K is equal to ln A minus EA upon RT. Minus EA upon RT. Now we'll take the, now we'll write 2.303 on both of the sides. And what we will be getting here, we'll be getting 2.303 K, sorry, 2.303 log K. Now we have the log of base 10 is equal to 2.303 log of A minus EA upon RT. Okay. Now log of K will be equal to log of A minus EA upon 2.303 RT. Arrhenius equation will be used in answering the definition type of question. Arrhenius equation likhiye. But this equation that we have written right now, it will be helpful in the solving of different numericals. So please write this down. Starting from Arrhenius equation till log K is equal to log A minus EA upon 2.303 RT. Please raise your hand when you are done. Just waiting for Assalamu alaikum, Samia. How are you, Samia?
Alhamdulillah, fine, sir.
बस क्लास में आप लोग आके चुपचाप ऐसे बैठ जाते हैं, कोई सलाम कलाम कुछ नहीं. हाँ, okay. Now let us look at this particular equation here. Let us look at this particular equation and what is going to happen if I increase the t. Okay, I'm going very slowly. Okay, I'm going to increase the t. That means this denominator will increase. That means the whole fraction. That means this whole fraction. No, denominator is increasing, whole fraction is decreasing. This whole fraction is decreasing, right? So this negative part is decreasing. If negative part is decreasing, then this particular right side will be increasing. RHS increases, and if RHS is increasing, LHS will also increase. Sequence समझ में आ रहा है? Yes or no? Please tell me. I increase the temperature, denominator increases. This, if the denominator is increasing, this fraction will decrease, and the negative part is also decreasing. That means this whole term will be increasing. है ना? 5 minus 2 और 5 minus 1 में कौन ज्यादा है? तो 5 minus 2 और 5 minus 1 में से 5 minus 1 ज्यादा है, right? So this negative part is decreasing. This whole RHS will be increasing, and similarly LHS will also increase. एक बार इसको फिर से ध्यान से देख लीजिए. If you have any doubt, then let me know. If not, then please write with me. It is evident that on increasing temperature, there will be increase in the rate constant K.
Sir, could you just repeat this part again?
नहीं, आप रिपीट कीजिए, आप बोलिए, हम आपको समझाते जाएंगे कुछ जहाँ पे आपको दिक्कत होगा।
Sir,
बोलिए।
you said as temperature increases, what increases, sir?
डिनोमिनेटर इंक्रीजेस, ये देखिए, ये डिनोमिनेटर है ना, ये वाला पार्ट इंक्रीज करेगा, है ना?
Okay.
ठीक है, अब आगे बढ़िए, समझ आ गया?
Yeah, sir. Only that part.
अच्छा, ठीक है। Okay, it is evident that on increasing the temperature, there will be increase in the rate constant K. Now we'll plot a graph between log K and 1 by T. Please write. Okay, 1 by T. First of all, we'll write the equation. What is the equation that we are going to use? We are going to use log K is equal to log A minus EA upon 2.303 R into 1 by T लिख सकते हैं इसको, है ना? I'm just writing this T अलग से. Now we have an equation. Now this is Y, right? This is Y, and this is my X, 1 by T. This whole thing is X. This will be what? M, and this will be C, है ना? M and C. So this whole thing is M. This is your X. This is your Y. And this is your C. Log A is C. Okay? So now let us draw a graph. So we have here 1 by T. And here we have log K. Now, as you can see, we will have an intercept and the slope is negative, right? And the slope is negative. And so we'll have a straight line graph going like this. Okay, so this point here, this point is what? It is the log A intercept. Okay, and the slope is minus EA upon 2.303 RT. Please write this down. Let me know when you're done. I hope you guys are done. Now, moving to Arrhenius equation at two different temperatures.
Sir, 1 second.
Sure, no problem.
Done, sir.
Right, next, Arrhenius equation at two different temperatures. So one point that we are going to write is that again the same thing, that for every 10K increase in temperature, 10 degrees Celsius or 10 Kelvin increase in temperature, rate constant becomes double. First point you will write that on every 10 degrees Celsius or 10K increase in temperature, the rate of reaction doubles. Okay. Next point. The ratio of rate constant at two different temperature at different temperature with difference of 10K is called temperature coefficient. It's called temperature coefficient. So what is temperature coefficient? Temperature coefficient is equal to K at T plus 10. That means rate constant at T plus 10 divided by K at this temperature T. K at T plus 10 and KT. ठीक है, ये ऐसे नहीं है, KT plus 10 नहीं है, ठीक है, please remember this, KT plus 10 नहीं है, this KT plus 10. और अच्छे से लिख दे क्या, KT plus 10. Done, yes or no, please tell me. This is for specifically two different temperature with a difference of 10 Kelvin or 10 degrees Celsius. I hope you guys know that if I talk about difference, then 10 degrees Celsius and 10 Kelvin, they both are the same. ठीक है, अगर हम 10 डिग्री सेल्सियस इंक्रीज कर रहे हैं तो केल्विन में भी उतना ही चेंज आएगा. अगर हम 10 केल्विन इंक्रीज कर रहे हैं, then we are going to have the same change in degree Celsius also. Okay, then guys, yes or no, please tell me. Okay, done now. Okay, thanks. Now let us suppose we are going to write now the Arrhenius equation at two different temperatures. Okay, Arrhenius equation at two different, that means completely different temperatures, T1 and T2. Okay, so please write Arrhenius equation at T1 and T2 for a reaction. Okay, that means the reaction is not changing. We are having the same reaction, and then we are going to see for T1 and T2. So we'll have different log K. The rate constant will change. We'll have log K1. This will be equal to log A, and log A is not changing. Why? Because log A is characteristic of a reaction. Reaction is not changing, log A will not change. Log K1 is equal to log A minus EA will also not change, divided by 2.303 R, and then T1 I will write. Why T1? Because we have K1 will be at temperature T1, and log K2 will be equal to log A minus EA upon 2.303 RT2. Correct? RT2. Now we'll do log K2 minus K1. This as 1 plus 2. 2 minus 1. Equation 2 minus equation 1. So we'll have log K2 minus log of K1. This will be equal to, देखिए हम इन दोनों को माइनस कर रहे हैं तो log K1 सॉरी log K2 minus K1 हो जाएगा, and you see here log A cancel हो जाएगा. Let me write it, log A minus EA upon 2.303 RT2 minus log A minus EA upon 2.303 R T1. Now, when the brackets will open, you can easily see that log A and log A will get cancelled, right? अरे हाँ ना कुछ तो बोलिए भाई, आप लोग इतना शांति में क्यों है? हाँ
Yes,
हाँ
sir.
ना कुछ तो बोलिए. Log A and log A will cancel. You can open it up. Now this minus and this minus will become plus. So I will write EA upon 2.303 R T1 minus EA upon 2.303 R T2, and log K2 minus log K1. This will become log K2 upon K1. Now we can further write this equation as log K2 upon K1 is equal to EA upon 2.303 R 1 upon T1 minus 1 upon T2. ठीक है, तो इसको आप ऐसे याद कर लीजिए. This equation is also helpful, or else if you take the LCM, then also it is going to be helpful. So what will be the, see, T2 minus T1 will happen. T2 minus T1 upon T1 into T2, right? So both these equations are helpful. You can remember any one of them. छोटा सा change है बस दोनों के बीच में. Nothing much. So the application of this reaction is that it is used to calculate the activation energy, and once the activation energy is found, then we can also calculate the Arrhenius factor, that is A. Okay, so we'll look at some reactions, some questions also. Please write this down first. Let me know when you're done. Please raise your hand when you're done.
Done, sir.
Done? Okay. Write a question. For a decomposition reaction, the value of rate constant for two different temperatures are, so we have K1, which is equal to 2.15 into 10 to the power minus 8 second inverse at 650 Kelvin, and K2 is equal to 2.39 into 10 to the power minus 7 second inverse at 700 Kelvin. Okay, you have to calculate the activation energy of reaction. Okay, you will take R is equal to 8.314. जब भी एनर्जी की बात आती है देन यू हैव टू टेक R इज इक्वल टू 8.314. ओके, joules per Kelvin per mole. You have everything, right? देखिए आपके पास क्या क्या है, आपके पास K2 है, K1 है, T2 है, T1 है ना, R भी है, 2.303 है. So linear equation is one variable. Please start writing and calculate this. अरे सॉरी, मेरा माउस है, माउस के अंदर ना एक बटन है जिससे एवरीथिंग गोज बैक टू द लास्ट प्लेस इट वाज. देखिए एक क्लिक में एक पेज, दूसरे क्लिक में दूसरा पेज, बट आई डोंट नो हाउ टू टर्न दैट ऑफ. कुछ तो सेटिंग होगा इसका. Guys, let me know if you need any help, okay? ऐसे बस बैठे मत रहिएगा. I hope you guys are doing this. Log 1.11. कितना आ जाएगा? 0.1 हो जाएगा और क्या? अगर आपके पास 11 रहता तो 10 लेके अप्रोक्सीमेट आंसर निकालते तो log 10 इज इक्वल टू 1 होता है. 0.11 हो जाएगा. 0.1 approximately if you want to ask me.
So using the calculator, it will be 0.04.
Log 1.1 ना. We'll have to calculate, I think. Log 1.1 इसको हम लिख सकते हैं log 11 into 10 नहीं 11 by 10. So log of 11 minus, oh sorry, log of 11 minus log of 10 होगा. My bad guys, my bad. Then I think you are coming closer. Yeah, then I think you are coming closer. Log of 11 will be somewhere around 1.04 minus 1 is equal to 0.04. My bad, Sarah. But आपका log का वैल्यू इतना नहीं आना चाहिए. I don't think that should be your log value. I hope you are doing K2 upon K1. जो टेम्परेचर ज्यादा है ना उसी के ऊपर रखा कीजिए हमेशा. And in most of the questions you will get that temperature as K2 only. Again, if you need any help, please let me know. I think you should be getting that as 11.1 now, Sarah, not 1.11. 10 to the power minus 8 है and minus 7 है यहाँ पे. Yes, Sarah.
I added the one later on, so it will be 1.04.
अच्छा, you added बाद में 1.04. हाँ ठीक है. तो log 11 is equal to 1.04. Okay. Okay, see, I hope you guys are not calculating यहीं पे सारा कुछ. Okay, please see. Log of K2 upon K1. ठीक है, चलेगा. Not exact, but it is fine. Log K2 upon K1, it is equal to how much? EA upon 2.303. And in bracket, what do we have? T2 minus T1 upon T1 into T2. हाँ ठीक है, approximately सही है सारा. Now log K2 upon K1. So log of K2 is 2.39 into 10 to the power minus 7 upon 2.15 into 10 to the power minus 8. This will be equal to EA upon 2.303. T2 minus T1 is equal to how much? 700 minus 650. Divide by 650 into 700. Okay, now this part was a bit difficult. आपको ये चीज solve करना था. So I hope all of you got this as log 11.1, or you must have got it as log 1.11 into 10. This will be equal to EA upon 2.303. And here we have 50. And here we have 650 into 700. Just keep it like this only. And now log 1.11 is equal to 1.04, which is equal to EA upon 2.303. अच्छा, R नहीं लिखा मैं, सॉरी, R मिस हो गया है. R भी लिख लेते हैं यहाँ पे. R is equal to 8.314 into 50 upon 650 into 700. Now EA is equal to, EA यहाँ पे सारी चीजें उधर चली जाएंगी, तो 1.04 into 2.303 into 8.314 into 650 into 700. This whole thing divided by 50. Okay, so you can cancel these things out. कुछ cancel करके आप लोग इसको approximately एक आंसर निकाल के रखें. ठीक है, multiply all of these things. ये 50 को तो पहले हटा दीजिए आप, है ना. So 50 can be cancelled. 0 by this 0 and 5 ones are, and then how much? 5 fours are. So you just have 1.04 into 2.303 into 8.314 into 650 into 14, not 70. अच्छा, एक वैल्यू आप लोग याद करके, one thing that I think I should give you is 2.303 into 8.314. ठीक है, 2.303 into 8.314, it is equal to 19. So I think this value is important. You should remember this value. 2.303 into 8.314 is equal to 19.14 to 650 into 14. अच्छा अहमद, कैन यू टेल मी वन थिंग? अहमद,
यस सर।
आपका नाम जो है लर्निवियो में मोहम्मद फायज करके क्यों है?
वेट सर, आई डिडंट सी दैट एक्चुअली।
आवाज कट गई आपकी। डिड नॉट, नहीं नहीं, यहाँ पे नहीं, जूम कॉल में नहीं, जो रजिस्टर्ड है ना आपके, मतलब
ओह यस सर।
अटेंडेंस वगैरह। क्यों? आपका नाम अहमद फायज है, मोहम्मद फायज?
सर अहमद फैज।
तो मोहम्मद फायज किसका नाम है?
सर आई डोंट नो सर।
तो आप लर्निंग में बोलिए कि प्लीज चेंज माय नेम टू मोहम्मद,
या ओके
चेंज माय नेम टू अहमद फायज। ओके
ओके सर।
ओके। क्या हुआ, अभी भी आप लोग आंसर नहीं दीजिएगा क्या? हाँ, सारा और अहमद के अलावा किसी ने आंसर नहीं दिया अभी तक। हाँ, फातिमा, मरियम, किंसा, किंसा इज हियर? नो, किंसा इज नॉट हियर। रजान, सारा, सारा ने दे दिया। वाफिया, मल्टीप्लाई कीजिए, आंसर दीजिए। अब तो बहुत सिंपल हो गया। Also, you will do one more thing, is that now you will remember this equation as log k2 upon k1 is equal to EA upon 19.14 into T2 minus T1 upon T1 into T2। ठीक है, 19.4 2.303 into R is equal to 19.14। 19.15 कर लीजिए, 19.147 है एक्चुअली, 19.5 कर लीजिए, 19.15। व्हाट हैपेंड फातिमा? आंसर अभी तक क्यों नहीं आया? मल्टीप्लिकेशन नहीं हो रहा क्या आप लोग से? डांट सुनिएगा। अच्छा अभी आया, बिल्कुल ठीक है, चलिए। रजान, व्हाट हैपेंड टू यू? यस रजान, सेंड दी आंसर। हाँ, मल्टीप्लाई नहीं कर, चलिए ठीक है, ये तो आप लोग छोड़िए, तो हम अब आप लोग खुद से कीजिएगा, बहुत टाइम दे दिया हमने यहाँ पे, मल्टीप्लाई करके नहीं हो रहा है आप लोगों से। राइट, नेक्स्ट फैक्टर्स अफेक्टिंग। फैक्टर्स अफेक्टिंग rate of reaction। ठीक है, so this is the last topic now। In some of these factors we have already done, some of these factors we have not done. So there are 4 factors that we will be talking about. Number 1 is concentration of reactant, concentration of reactant. Second is physical state of reaction. Third is temperature. And fourth is presence of catalyst. Right, for the first one, concentration of reactant. So we have already seen, according to what? According to the law of mass action, the concentration of reactant increases, then the rate of reaction also increases due to increase in the number of collisions, right? So first of all, you write the rate of reaction increases on increase in amount of reactant. according to law of mass action, as the number of collision would also increase. Okay, right, next, physical state of reaction. Physical state of reaction. Now, in physical state, we have seen that homogeneous reactions reaction is greater than the rate of heterogeneous reaction. Homogeneous reaction, that means in which all the species, all the chemical species are in same state. Heterogeneous means the chemical species are in different states. Now, one is liquid, one is gas, and so on. Now, for homogeneous, you will write next point. For homogeneous reactions, we will have solid plus solid. This will be the slowest, followed by liquid plus liquid, followed by gas plus gas. What does that mean? If I have all the reactant in solid, that will be a slow reaction, followed by liquid, and then followed by gas and gas. At the next, third one, temperature. For temperature, you will write as the temperature increases, the kinetic energy of reactant increases. Therefore, number of effective collisions increases, which leads to increase in rate of reaction. Done, everyone? Yes or no? Please tell me. Last, you will write effect of catalyst. Fourth is catalyst. Fourth is catalyst. Temperature लिख के please raise your hand once you're done with temperature. देखिए, first of all, what is the catalyst? हाँ, बताइए.
So it's 7 o'clock and my tuition's now it's gone back to the old timings of my math tuition.
So math tuition कब से कब हो रहा है आपका?
Sir, from today onwards it's by this timing. Before that he was taking in the morning because we didn't have school.
Oh, okay. So now you are going to leave.
Yes, sir.
Practice part आपका recording से देखिएगा.
Yeah, sir. I'll watch from YouTube.
Okay, fine. If you have any doubt, फिर अगले क्लास में बताइएगा, ठीक है?
Yes, sir. Thank you, sir.
Thank you. Okay. The effect of catalyst. Now, what is a catalyst? First of all, we'll understand that. Many people, they have a misconception that catalyst does not take part in reaction. First of all, it take part in reaction. Okay. What is a catalyst? Catalyst is a substance which increases the rate of reaction, which increases the rate of reaction without undergoing permanent change. Without undergoing permanent change. Okay. I'll write 2 remarks. Catalysts take part in reaction but doesn't get consumed in the reaction. ठीक है, दैट मींस जैसा आपने डाला था वैसे ही निकल के आ जाएगा रिएक्ट करा के. ओके, रिएक्ट करा के वैसे ही निकल के आ जाएगा. लेट मी टेल यू व्हाई वी नीड कैटलिस्ट एंड ऑल थिंग्स, बट यू विल नॉट राइट दोस थिंग्स. ओके, यू विल नॉट राइट दोस थिंग्स. Have you written till this remark? Yes or no? Please tell me. Have you written till remark? Fatima, Sara, and Wafia?
Yes, sir.
ठीक है, अब सुनिए यहाँ पे बिल्कुल आसानी से. Let us suppose we have a reactant A and we have a reactant B. Now both of these are stable reactants. Okay, this is also stable and this is also stable. That means A and B, if both are stable, they are what? Unreacted. So this reaction in which they are forming AB, this is very slow. Why? Because the activation energy is very high. है ना? This is stable, that is both of these are stable. That means देखिए activation energy high क्यों है? Both are very stable. That means they are here. And for reactions, you need to go till here. This is the activation energy, right? And इस वजह से ये क्या है? This is very difficult to go above this particular hill and then come down for the formation of product like this. Okay, even though the product is thermodynamically possible, this reaction is going to be slow. But let us suppose that we have the reactant here. Then the activation energy is what? It is not very high. Enough. So we have A and B which are both are very stable molecules and they are unreactive. Now we add a catalyst. Let us suppose we add A plus B and C. Now C is a catalyst and these catalysts are always very reactive. Catalysts are the most reactive things in the reacted molecules. This catalyst, what it will do? It will bring this A and B together. So let us suppose that this catalyst, it binds with B and A, both of them. So you have C, it binds with B also, and it binds with A also. Now, since A and B, both of them are stable, they were very far away. But now what is going to happen? Now this catalyst is binding with A and it is binding with B also, and then it is getting A and B closer. And now they can combine and then they can react. So this is known as activated complex. Activated complex. Now once A and B will react, I will get AB plus C. This catalyst will be out as before also. Okay, as before. That means what we can see is catalyst is taking part in the reaction, but it is not getting consumed in the reaction. It is not getting any permanent change in the reaction. So all of you understood this? Yes or no? Please tell me how the catalysts work and why do we need a catalyst? Yes or no? Yes. Now, as you can see, this complete reaction is different. This is a whole different reaction than this one. 1 and 2 are different reactions. Why? Because in 1, we have A and B as reactant. And in 2, we have A, B, and C as reactant. And also, if I look at the transition state here, it will be having only A and B molecule. The transition state here and the transition state here, both are what? Different. And that is why you will write progress of a reaction in presence of catalyst. Reaction in presence of catalyst. Now, if that reaction is different, its activation energy will also be different. Okay. So that is the main thing about catalyst. It changes the activation energy. So you'll write here the energy. And here we have the progress of reaction or the reaction coordinate. Now, first of all, we will make for, first of all, अच्छा एक काम करते हैं, wait a second. थोड़ा देर आप लोग इंतजार कीजिए, हम आप लोगों को, I think I should just paste a photo rather than making a photo. Okay, let me explain this first. Now, we have this black line. Okay, so this black line here, this is talking about the without catalyst. That means we have this in black line, we have A plus B is giving me AB. Okay, now this pink type of line, this red line here, it is with catalyst. That means we are having A plus B plus C. It is giving me AB plus C. Now, so both of these are different reactions, but we are getting the product same. We are starting with A and B, and we are getting what? We are getting AB. We are starting with A plus B, and we are getting in the product AB. Okay, so please write this down. So EA is activation energy without catalyst. Now we have EA dash. This part here, which is smaller, it is activation energy with catalyst. Okay, activation energy with catalyst. इन दोनों EA को छोड़ दीजिए, आप इसको मत लिखिएगा. ये फॉरवर्ड और बैकवर्ड दोनों के बारे में इतना आपको जानने की जरूरत नहीं है. Done everyone? Yes, Anu, please tell me. Fatima, Sara, and Wafia.
No, sir.
अच्छा लिखिए आराम से लिखिए. ये EA डैश और EA में F लिखने की जरूरत नहीं है. ओके, इज एक्चुअली टॉकिंग अबाउट द फॉरवर्ड रिएक्शन. Raise your hand when you're done, okay? Okay. Write one topic which will be helpful for you guys in some numericals, okay? So write first order gaseous reaction. Now, let us suppose that we have gas A. It is giving me B gas and C gas. Generally, decomposition reaction में ऐसा होता है. Now, at time is equal to 0, I will say that this is P initial, in which we have only the reactant molecule, and this is 0 and this is 0. We don't have any product here. We don't have any product here. Now, if this is initial, what will be the change? In change, what will happen? From the change, we will say that P is getting reacted. If P is getting reacted, then P will be formed, and this here also P will be formed. Okay. Now, after change, that means final stage is what? Finally, we will have Pi minus P, and here we'll be having P, and here we'll be having P. Okay, so all of these are what? Pressure of gases. P initial is pressure of gas, and then 0, 0, and P is getting reacted. So P is getting formed and P is getting formed. And then at final, we'll have Pi minus P. Here we'll have P, and then here also we'll have P. Now, in this final stage, this final is also known as equilibrium. Okay, so at, we should write finally, the total pressure will be equal to Pi minus P plus P plus P, which will be equal to Pi plus and minus will cancel each other. Pi plus P. Correct? Yes or no? Please tell me. हाँ या ना, जल्दी बताइए. सही है? फातिमा, सारा एंड वाफिया.
Yes, sir.
ओके, चलिए. अब एक ना थोड़ा कंसेप्चुअल सवाल हम आप लोगों से पूछ रहे हैं. आप ये बताइए, यहाँ पे वी हैव थ्री थिंग्स. वी हैव P total, we have P initial, and we have the change. Okay, what is how much of the gas is getting reacted? Now, out of these three, A, B, and C, you tell me which cannot be measured. बताइए जरा, कौन सा ऐसा है जिसको हम मेजर नहीं कर सकते, सिर्फ कैलकुलेट करके ही आ सकता है, फॉर्मूले की ही थ्रू आ सकता है, हम उसको मेजर नहीं कर सकते. फाइनल वाला P, इनिशियल वाला P, या चेंज वाला P? ओके, सारा इज आंसर्ड. फातिमा एंड वाफिया, आपको समझ में आया सवाल? Fatima and Wafia, did you understand the question? Fatima, Wafia?
Can you explain it again?
How many terms do we have in this equation? Pt is equal to Pi plus P. Tell me.
3 terms.
How many terms? 3 terms. One is P total. That means finally what is the pressure? We have P initial, and then we have the change. I'm asking, see, you know that pressure can be measured, right, Fatima? What is the tool that is used for measuring pressure? क्या यूज करते हैं प्रेशर मेजर करने के लिए? फातिमा टेल मी व्हाट डू वी यूज? सारा, वाफिया, एनीवन? व्हाट डू वी यूज टू मेजर प्रेशर? व्हाट डू वी यूज टू मेजर प्रेशर? नहीं पता किसी को? अरे रे रे रे, इट इज रिलेटेड टू वन ऑफ द यूनिट्स
Barometer.
ऑफ, हाँ करेक्ट सारा, वेरी गुड, बैरोमीटर. ओके, सो वी कैन मेजर प्रेशर, लेकिन कैन वी मेजर द टोटल प्रेशर, इनिशियल प्रेशर या चेंज, है ना? Out of these three, there is one term which we can never measure from barometer. We can only calculate that. अरे देखिए भाई आप, this is our chamber. हाँ करेक्ट, फातिमा ने सही कहा अभी, वेरी गुड. So we have this chamber, we put here gas, गैस डाल दिया हमने. It is in the initial stage, we measured the pressure, है ना? We have this closed chamber, we will measure the PI. Now we will heat it or do something, then after a while what we'll see that pressure, we will see that pressure has changed. In final stage we will get the PT. What we can never measure is P, that is the change. That is why we will convert this equation in terms of P, है ना? क्योंकि P ही ऐसी चीज है जिसको हम लोग मेजर नहीं कर सकते. So P will be equal to P total minus P initial. Now if there is anyone who is asking a question about P total or what will be the final pressure, what will be the initial pressure, then that one guy is a fool. Why? Because we don't need to calculate if we already have a measurement tool. ठीक है, आपको यहाँ पे एक स्क्वायर दे दिया है, ठीक है, उसका एरिया दे दिया है, और फिर पूछ रहा है आपको कि लेंथ क्या है. अरे भाई, जब लेंथ आपको जानना है, देन वी हैव रूलर्स ना, we can take a ruler and we can just measure it. We don't need the area for that. So if we have a simple tool for it, we will measure it rather than calculating. लेकिन फिर भी आपके पास सवाल आएंगे. If you get any of these type of question, पहले ऐसे सोचिएगा कितना बेकार सवाल बनाने वाला है. उसको ये भी नहीं पता कि इनिशियल प्रेशर और टोटल प्रेशर जो है हम लोग बैरोमीटर से या फिर मैनोमीटर से मेजर कर सकते हैं. अफसोस करके फिर उसका सवाल बना दीजिएगा आप लोग, ठीक है? बट अंडरस्टैंड द साइंस बिहाइंड इट. Why do we write P is equal to PT minus PI? Because both of these things can be measured. Okay. Now we'll write the K for first order reaction. किसी को याद तो नहीं होगा, तो K is equal to 2.303 divided by T log of A naught upon A, right? Log of A naught upon A. Now we know that this A naught is what? Directly proportional to the initial pressure, PI, right? And what is this A? A will be directly proportional to what? The total pressure, yes or no? A जो होगा आपका, this is the remaining part, right? This is the remaining part. So wait. A will be the remaining part. That means it is A naught minus, it is A naught minus change. So that means it is equal to PI minus P. Sorry, is equal to PI minus P. Okay, now we can write K is equal to 2.303 by T log of P initial upon PI minus P. अब P तो हम लोग को पता नहीं है, right? We don't know P, but we can write this P in terms of PI and PT. This will be equal to 2.303 divided by T log of P initial upon PI minus, what is P? P is equal to PT minus PI. Now this minus and minus will become plus PI. To PI minus PT. Write this down, let me know when you're done. Done, guys? Yes, no, please tell me.
Yes, sir.
Okay. We'll do a simple question. For reaction SO2Cl2, which is a gas, gets converted to sulfur dioxide and chlorine. Both of these are also gases. They have said that we have done two experiments. Okay, we have done two experiments and we have measured the time for it and we have also measured the pressure for it. Now, experiment 1 was done at time 0. That means initially the pressure was equal to 0.5. Then experiment 2, that means we took the measurement of pressure at, let us say, time is equal to 100 seconds. Okay, time is in seconds. So after 100 seconds, we saw that the pressure was equal to 0.6. You can write ATM. Okay, ATM. Now they're asking, calculate the rate constant. Now please see all these steps you have to do. Okay, you have to do all these steps. First of all, you will write SO2Cl2 is giving me SO2 plus Cl2. Now at time is equal to 0 initially. देखिए तीन चीज दिखाई जाती है हमेशा. आइस टेबल बनाते हैं. Initial, change and at equilibrium. Equilibrium means when the pressure is not changing. That means आखिरी में final pressure जो होता है, that is equilibrium. So SO2 initially we will have how much? 0.5 atm, right? इसको हम लिखते हैं ऐसे P initial करके 0 and 0. This P initial thing you will write for each and every reaction. यहाँ पे 0.5 फट से मत लगा दीजिएगा please. Now change will be P. Here we will get P. Here we will get P. Please keep in mind the stoichiometric coefficient. Here it is 1 1 1. तो अभी ठीक है. Equilibrium में it will be what? Pi minus P. Here we'll have P and here also we'll have P. Now then you will write P total is equal to Pi minus P plus P plus P, which is equal to Pi plus P. And then we will write P is equal to PT minus Pi ना, PT minus Pi. पहले भी ये लिखा था ना हमने. ठीक है, चलिए. Now we have to also see this equilibrium. Okay, this is also very important. Pi minus P is also very important because that is the remaining SO2Cl. Now we are going to write what? क्या था equation? K is equal to 2.303 divided by time log of initial. This is the initial and at equilibrium. दोनों लिखना आपको. Divided by Pi minus P. So log of Pi upon Pi minus P. अच्छा, P is equal to कितना आ रहा बताइए तो जरा. P टोटल था हमारे पास 0.6 minus 0.5 which is equal to 0.1 है ना. 0.1 हो जाएगा ये. Which is equal to 2.303 divided by T log of Pi is 0.5 divided by 0.5 minus 0.1. This is K. T is equal to 100 na, 100 seconds. So you'll write 2.303 divided by 100 log of 0.5 upon 0.4. Please write this. K कैलकुलेट कर लीजिएगा घर में, अभी मत कीजिए, ठीक है. We'll calculate it later on. 5 by 4. 5 by 4 is equal to again 1 point something. 1.04 कुछ आ जाएगा. अच्छा, इतना लिख लिया आप लोगों ने? yes or no, please tell me. Fatima, Sara
Yes,
and
sir.
Wafia. Okay, right. Next we have same equation experiments here, but we have a different reaction. So I just want to show you guys how it is going to change with the change in stoichiometric coefficient. So you have 2N2O5 and N2O5, it gets converted to N2O4 plus O2 gas. Okay, so here also we'll make the I stable, है ना? Here also we are going to make the I stable. So initial is equal to how much? Initial is equal to 0.5. That means we will write Pi. Here we have 0, here we have 0. Now the change is of P. Now the change will be of P. And now you can see that here we are having 2 now. So you write 2P as a change. This will get 2P and this will get P. जो stoichiometric coefficient होता है उतना ही change भी आप कर दीजिएगा. Okay, that same number of change will be also there. Now you are going to write Pi minus 2P, and this will be what? 2P, and this will be P. So P total is equal to Pi minus 2P plus 2P plus P. Now this is still the same. So P total is equal to Pi minus Pi plus P, and we can write P is equal to P total minus Pi, which will be also again equal to 0.1 atm. Clear है यहाँ तक? Everything is fine, I hope. Now please see next. For K will be equal to 2.303 divided by 100 seconds. Log of P at initial and P at equilibrium is Pi minus 2P. ये important देखिए, यहाँ पे क्या है? Pi minus 2P. So this is going to change according to the stoichiometric calculations. Okay, so we can write this as 2.303 divided by 100 seconds. Log of Pi is equal to 0.5 upon Pi minus Pi is 0.5 5 minus what are we going to get here? 2P is equal to how much? 2P is how much? 2P is how much? 0.2 है ना? 0.1 into 2 will be equal to 0.2. अरे हाँ यार, हाँ कुछ तो नहीं बोलते हैं.
Yes, sir.
2 into 0.1. ठीक है, तो ये हो जाएगा क्या? 0.2. And then this will be equal to 2.303 divided by 100 log of 0.5 divided by 0.3. ठीक है, खत्म चैप्टर. Chemical kinetics is done. यहां से छापिए. I hope Fatima, Sara, and Wafia, you understood both of these. Yes or no? The questions.
Yes, sir.
Yes. Okay. Now again, please redo this. Okay. इसको ना फिर से कर लीजिएगा एक बार. Let me know if you are done writing this. Okay. If you are done writing this, please raise your hand. अच्छा, नेक्स्ट चैप्टर कौन सा स्टार्ट करें जरा बताइए. हाँ जी, सारा आप बताइए नेक्स्ट चैप्टर कौन सा स्टार्ट करें.
In high school, तो sir is doing.
आपकी आवाज ही नहीं आ रही है.
Hello.
हाँ जी बताइए.
In my school, my sir did alcohols and then he did aldehydes. Like he's doing aldehydes.
हाइड्रोअल्किन भी हो गया.
Yes.
तो हाइड्रोअल्किन स्टार्ट करेंगे ना, मतलब एल्डिहाइड कीटोन्स तो अभी ठीक है. हाइड्रोअल्किन. फातिमा आप बताइए.
सर अभी छुट्टियां चल रहे हैं और सर ने केमिकल काइनेटिक्स खत्म नहीं करे।
खत्म नहीं करा है अभी। वाफिया आप बताइए। वाफिया यू टेल मी।
Just completed chemical kinetics.
We are still doing chemical kinetics.
Now we completed.
We complete. So next chapter. Next chapter. Here also we completed chemical kinetics, na? So you don't know. Yes, Wafia, you don't know. Hello, alkenes. ठीक है तब हालो अल्किन हालोरीन स्टार्ट कर देते हैं फिर, है ना? फातिमा, यू आर फाइन विथ हालो अल्किन हालोरीन?
So I'll ask sir what he will do after chemical kinetics and I'll inform you.
मान लीजिए हालो अल्किन हालोरीन स्टार्ट नहीं किया उन्होंने, है ना? आप 3 बच्चे हैं यहाँ पे। फातिमा के यहाँ तो चलिए ठीक है, हालो अल्किन हालोरीन चल रहा है। नहीं सॉरी, सारा के यहाँ, सॉरी, सारा is having halo alkene halorine. Let us suppose Fatima's school, they started D and F block or coordinate chemistry, something like that. And let us suppose Wafia school, they started with biomolecules or polymers. Then what I will do? Tell me.